Problem number 3 states, the ice cube cosmic ray detector is based on light sensors buried under the Antarctic ice. Holes are drilled in the ice using hot water to create cylinder cavities filled with liquid water, which are as deep as 2,450 meters. While the water is still liquid, instruments that can detect light flashes from cosmic rays are lowered into the water and eventually frozen back into the ice. What is the gauge pressure at the bottom of one of these holes before it starts to freeze again? So they want us to take the density of water as 1,000 kilograms per meters cubed and gravity is 9.8 meters per second squared. And then they want us to give some context as far as why are the physicists drilling these holes. Okay, so this one's pretty straightforward. I've drawn a figure here showing we have our Antarctic ice with the hole being drilled down at a depth of 2,450 meters. We have our pressure at the bottom here that we're going to calculate. And then we have our pressure at the surface, which is equal to atmospheric pressure. They've given us our density of water and the gravity. So we know our equation for the hydrostatic pressure at a depth D is going to be equal to the atmospheric pressure, because that's the pressure at the surface, plus the density times gravity times the depth. We also know that pressure gauges read as the pressure minus 1 atmosphere. So we can just use the equation. Our pressure gauge is going to read pressure minus 1 atmosphere, which we can convert to P as being equal to 1 atmosphere plus density times gravity times depth minus that 1 atmosphere. So we can just cancel out those atmospheres, and our pressure gauge is just going to be equal to density times gravity times depth, which we've been given all those variables. So we just plug those in, and our pressure gauge is going to be equal to, convert that to kilopascals, 24,010 kilopascals, which we can also convert to atmospheres if we wanted to. And that would be 237 atmospheres, but it's a pressure gauge, so we're going to leave it at 24,010. And as far as the context goes, these cosmic rays, the reason that they're drilling so far down is because if they tried to detect these rays at the surface, everything would basically be thrown off. Their detectors would be thrown off by all the other things going on at the surface, like Wi-Fi and sound waves and radio waves and all those other things going on. So by drilling down that far, they're able to still detect these high energy rays and not be thrown off by everything we've got going on at the surface. So that is why the physicists drill so deep to detect these rays. And this all ties into what we're learning in chapter 14 with measuring pressure at different depths, 14.3 specifically.